In this video, we're going to figure out how to use a reference angle to evaluate secant, cosecant, and cotangent. We're going to do actually all six, but we are going to focus on these three since we've done the others. Okay, so the first thing I want to show you, this is something to help you out. I like to use X's and Y's. To me, it makes more sense, and I don't have to memorize anything. But if you would like to memorize this phrase here, this will tell you what the signs are, which ones are positive in which quadrant. So what we do in quadrant one, all of our ratios, notice there are 6 there, all of them will be positive in the quadrant one. Okay, for the second quadrant, we put S, the smart, right? All smart. And this has the sine and its reciprocal function. Remember, sine and cosecant go together. They just flip over. That's all that is. So a sine, a smart, and all sine and cosine are positive in the second quadrant. And third quadrant, T, a smart trig. Okay, well, that's tangent and cotangent. Those go together. And the last one is cosine is positive in the fourth quadrant, and secant goes with cosine. I like to memorize that all x's and y's are positive here. X's are negative, y's are negative here. Both are negative here. X is positive, y is negative there. And that helps me figure out sine, cosine, and tangent because I have those memorized based on x's and y's. All right, so you can use this if you would like. It will tell you where they are positive. I had a different acronym. I think that was given to me. But what I have found in the long run, if I just understand that sine is y and cosine is x, I can get to all of these just based on my knowledge of the Cartesian plane. All right, we're going to do a problem here, finding a reference angle in radians and using that to find all 6 ratios. Okay, so we have negative 7 pi over 4. That definitely is bigger than one rotation. So this is going to be, I don't want to use an equal sign here, even though I wrote it. I think I'm going to do this instead. Okay, negative 7 pi over 4. Remember, if I want to get to a positive, I'm going to add 2 pi, but that's going to be 8 pi over 4, right? Because 8 over 4 is 2. If I do this, I'm going to get a pi over 4. Well, pi over 4 is quadrant 1, and it's the mid triangle, right? That's how we want to attack these. Quadrant 1, mid triangle. Well, since it's the mid triangle, I know the values are the same, and they have to be radical 2 over 2. And then our unit circle triangles are always 1 in the hypotenuse. So this is pi over 4, right? And now we're going to find all ratios. That angle is already there, but I just showed you how we got to it. Okay, sine is y, so that's radical 2 over 2. And then I know when I flip it, I'm going to get a rad 2, just based on past evidence. If you go look at the problem we did in the last video. Cosine is also is x, and it's also radical 2 over 2. And when I flip that, I get radical 2. Tangent, remember, is y over x, which is radical 2 over 2 over radical 2 over 2, which is just going to be nice, pretty 1. And when I flip 1, I get 1. These values are going to be consistent. They're going to show up a lot. This is why we spend so much time on that unit circle to get those values down. That way, when I do have the values down, to get to the new ratios, cosecant, secant, and cotangent, I don't actually have to do anything new. Just know which one goes with which and flip it over.